Greetings. In this video on construction cost estimating, we're going to look at the basics of estimating concrete. The agenda is estimating specifically linear concrete components. Here we see a couple pictures, an old school wheelbarrow, and two other ways today how concrete is placed, putting any components in place or installing components. We use the word placing. So the concrete is being placed here by way of a chute coming directly from a concrete mixing truck, and here on the right, concrete is being placed by a pump into appears to be a pier or a caisson of some sort, or a column, a large column that's being built. Perhaps, I don't know how far this goes down. I guess maybe it's for a bridge or something. I see a bridge beyond. Anyway, so estimating concrete, estimates shall include some information from the specifications or the general notes, what type of concrete is being used, what is the strength that the structural engineer has specified, the color of it, and any special curing and testing. So all these things affect the cost. Anything that affects the cost is of concern here. Where is information on concrete found? In the written specifications, foundation plans, structural plans and details, building and wall sections, and site plans. These are the top 5 places you would find information on concrete in a project. So concrete is estimated in cubic yards or cubic feet. Typically, we'll take dimensions from plans that are in feet, so we will calculate the cubic feet of the needed concrete, and then we will divide that by 27, and we will get cubic yards. So we'll have a smaller number because there are 27 cubic feet in 1 cubic yard. Okay, 27 cubic feet in 1 cubic yard. That's what this diagram shows. This is 1 cubic foot, and this is 27 of them, so that we get a smaller number, just a more manageable number to work with. All right, estimating linear components. The quantity of footings, columns, beams, and girders is determined by 2 things. Yes, pertains to slabs as well. Calculating square footage by multiplying linear feet by cross-sectional area. So we want to calculate the square footage. We're going to multiply the linear feet, so that is this direction, the linear feet of this beam, so call it 12 feet or something like that, by its cross-sectional area, which is this. This is the cross-section of this beam. So if we cut this beam in half and we looked in, we would see the rebar, 4 pieces of rebar coming across the bottom, 4 or 5, I guess. I'm not sure if these 2 pictures are truly the same or not, actually. I don't think they are. But anyway, that's the rebar across the bottom. That's the rebar across the bottom. This is a stirrup here, joining the top and bottom rebar, and that's what we see here in this diagram. And then we have the top, the rebar at the top, 2 pieces. Yeah, so that's not the same. We see 2 there, and we see 5 here. So the underside, the bottom, or the top. And so this is double reinforced, and here we see some precast beams with the same. A lot of steel rebar reinforcement across the bottom because beams are weak in tension, so they need rebar at the bottom, and then we see some other rebar coming from the side. So very similar, and these are possibly the heads of stirrups. Okay, so anyway, so that's what we're looking at, is the cross section. And again, let's call this 10 feet, and then here we would multiply that by 1 foot. So we're going to convert our inches into feet. So 1 foot, and 2 feet in this direction is 2. So that's actually easy. So this is 2 square feet, and if that's 10, then we have 20 square feet, or cubic feet. At that point, it's cubic feet of concrete. 1 times 2 times 10. Okay. Converting cubic feet into cubic yards, and then we would take that number. So I could just actually bring up the calculator really quickly. 1 second. Here's my handy calculator. So 1 foot times 2 feet is 2, obviously. 1 times 2 is 2. And then we said times 10 feet. And now we have 20 cubic feet, and to get the cubic yards, we would divide that by 27. So this is 0.74 cubic yards, and we typically work to 2 decimal places. So 0.74 cubic yards is what I would say. 0.74 cubic yards. Okay. All right, so here I was doing the example, and so in my example, I didn't look ahead on this slide, obviously, but same thing, and then we would, so what did we just have? That's not 0.25. Whatever we just calculated with 10 feet is obviously twice that, and that's the answer there. So, okay, footings. So estimating concrete footing. So here we have step footing. So this is what the this is where the house meets the earth. Basically, this is what supports, or we take the weight of the house, and this is what distributes it into the earth. The footings. This is the very first thing that's installed. So these are step footings. Here we see a footing right there, and so we would be multiplying its height times its width times its linear feet. And that's what we would be doing here. So we'd have to calculate all these linear feet. And one important thing that we will have to do, and this is a good place to point it out, is when we calculate the linear feet of this run, for instance, then this one is coming into it. We don't want to double count this area. We don't want to double count that area, and we don't want to double count this area. So we are going to have to usually in architecture plans, when we're given dimensions, they're to the outside of the footing here. So we're going to have to do some math, and we're going to have to move this dimension. Like, so whatever this footing is, if it's, I don't know, call it if it's 50 feet to here, and if this is 2 feet wide, we're going to have to take that 50 feet and back up 2 feet and call it 48. So the linear feet of this run is 48, because we don't want to double count that. So that's a lot of maneuvering with the dimensions we're going to have to do. Step footings, we pointed that out. So more footings. So here, these look like they might have been poured directly into the earth. If the earth is stiff and solid and stands up, if we could dig a trench and the structural engineer allows it, they'll allow you to not use forms like this. That's what might have happened there, because it looks like the earth is right up to it already, and yeah, so that's what it looks like to me. And here we have formwork. So again, we would have to calculate all of this linear feet, and again here we would want to capture that corner, and then here we would capture that corner, and it looks like there just might be a sliver in between them. So we don't want to double count. Or we could count this length and then stop this one here. Stop this one here, and then we could make this a wall. Either way, ends up at the same thing. But you could see, and here's like a foundation for like a bay window or something like that, so we would have to calculate that additional piece as well. All right, so what this looks like in plans. So this is a good-looking construction detail, nice and clear. So there's the footing right there. And here's the rebar there and there. It's pointing out as continuous rebar. Insulation here, we're pointing to here, it's slab insulation. So this is to help keep the basement floor warm. And on top of the footing, we have the foundation wall right there. And we see rebar up and down there. And that's what it says, 4 bars at 18 inches on center. So that's that. Additional vertical bars, 2x10 mud sill, 2F. Where are we pointing there? I'm not sure where that's pointing. Anchor bolts from all corner locations. Oh, this is for the anchor bolts. Okay, so I still don't see that it's really pointing at anchor bolts. I would expect them to be up here. And then there's rebar again, pressure treated sill, where the first place where the wood meets the concrete is our pressure treated sill, and then we have our concrete slab coming in. It's 4 inches deep, and below it we have our vapor barrier, and below the vapor barrier again we have the insulation, and then it looks like crushed stone down there as well. So a lot of information in there. And it does give us our footing dimensions. It is 14 inches wide and it is 8 inches tall. So just to bring up again this chart here, yeah, we could look at that chart, that's fine. So this is my inch to foot conversion table. So if we have 1 foot 2, 1 foot 2 inches is 1.16. Let's get the calculator back here quickly. Put that over there. This like a claps down. So this chart is the inch to foot conversion. So 6 inches equals 0.5 feet. 9 inches is 9 inches is 3/4 of 12, right? 12 inches is a foot right there. So that's what we see there. So 12 inches equals 1 foot. 9 inches equals 3/4 of a foot. And what we were just talking about right there, so I'm just going to collapse this down a little bit. We have 1 foot 2, so that is going to be 1 foot and 0.16. So that is 1 foot 0.16. That is 1.16 feet right there, times 8 inches. 8 inches is 2/3 of a foot, or 0.66, right? There's our 12 inches. 8 inches is 2/3 of that, so 0.66, 2/3. So we will multiply this 8 inches, 0.66, times 0.66 equals. So that is the two-dimensional area of that footing right there. Let me get my calculator back. Okay, that is the two-dimensional area of that footing. So the question then, in the third dimension, so that you could say that's square feet, 2 dimensions. And then if we want to move into cubic feet, we're going to have to get that third dimension. So how long is this footing? And then, so that's where we come back here, and we'd have to figure out how long this thing goes on for. Okay, so that is that. So that's a nice looking drawing. That's good information there. Here we have a slab on grade, essentially. So, and the depth of the footing is, of course, related to the frost line. So here, with no footing, this is probably like a house in Florida or something like that. Here in Philadelphia, we have to get down 3 feet. You know, the warmer the weather, then the more shallow the footings. Okay. All right, and then on top of the footings, we have walls. Often, if we have an occupiable, these two pictures are of an occupiable basement, it appears, and they are the foundation walls. And here are the anchor bolts at the top of them. This is a ledge for bricks, and then all this gets backfilled, of course. And then here we see some column footings. So we expect there to be probably steel columns supporting a beam, kind of jog here in some strange way, but somehow, some configuration, there's a beam up there. This looks like perhaps the garage back here, and it looks like the kind of interesting here, actually, just to point it out, how the foundation wall is actually coming up a little bit higher than the slab. That's not too common, actually. That's usually not the detail. Usually they end at the same place. But that's what might be happening here as well, actually, back near the garage. Okay, so this is a plan. This is like an illustration or kind of an old-fashioned looking plan, but it has good information in it. That's why I included it. So here is the foundation wall right here. Let's just cruise around and let's see what we see first. So I see dimensions on the outside. I see here dimensions. So go back to where I was. That's the foundation wall, and the dashed lines below are the footings. Okay, so when we're looking at that plan right there, we're kind of coming right through here. We're cutting through somewhere. We're cutting through the wall here, and so we see the wall, but the footings we don't see. This point right here and this point right here, that's, you could kind of say, buried in the earth. It's below the cutting plane. So that is why it is depicted here in dashed lines, right? So that's the wall and that's the footing. So we see the footing is 16 inches wide. Here is 24 inches wide. That's kind of strange. Well, I see that there's an additional ledge here for some reason. On the I was going to say it could be a brick ledge, but it's on the inside, so I don't really know what that is yet. But that no matter. I'm just saying it's strange because if that's 16, this looks like more. This looks like 16 at the most, so maybe it's not really drawn to scale. But for whatever reason, this part of the wall here is 24 inches wide. What else do we see here? So concrete footing. Okay, so that's telling us the footing size, which also does not correspond to this 16 inches here, so that's further confusing. So this would be a note to the architect to explain. I would have to ask this question if I was bidding on this job. So this is saying that this footing is 24 inches wide by 10 inches tall, and that doesn't agree with that. But no matter, you get the gist of what we're looking at. So here's the 12-inch wall, so that's good. 20 inches over at this location. So the width of this footing seems to be changing on all sides. 24, 24, 20, and 16. Kind of peculiar. But anyway, it's more about how we're reading the drawing. 2-inch concrete slab on dropped floor. I would guess that's on dropped floors. What's the floor here? Footings and piers. I don't see other information on the floor. So I'm not sure what this floor. I would imagine this is a concrete floor, and I would imagine that on dropped floor, I'm not sure exactly what that means, but I would think that it may be reinforced for like a fireplace or something, so maybe it's 2 inches thicker than the rest of the floor. I definitely assume there's a concrete floor down here. Anyway, here is a beam coming through the basement, and it is supported on columns or piers. Yes, 12-inch piers. Doesn't tell us what they're made of. Could be concrete or brick. And then below that pier is a footing as well, 18 by 18 by 10. So there are 2 of those, so we would add those to the estimate, of course. And let's take out the calculator one more time quickly, and the sheet, and let's just do a quick takeoff of one of those. All right, so this footing is 18 by 18. So again, kind of strange that it's written in inches, but that's 1 foot 6. So we have 1 foot is 1 foot, and then the additional 6 inches is, of course, 0.5. So this is 1.5 feet. So let's clear it. 1.5 feet times 1.5 feet. So that is the 2-dimensional area right there, 2-dimensional square footage of what we see there. But then the third dimension, so that we're going to go from square feet into cubic feet, is 10, and 10 is 0.83 feet. So we're going to take this and multiply it by 0.83 feet. And that is the cubic feet of that pier, the cubic feet. And then if we want to translate that into cubic yards, like this number is plenty small as it is, but ultimately everything becomes cubic yards. That's how we order the concrete from the concrete plant. So we would divide, well, let's say there are 2 of them. So let's multiply this by 2 actually at this point. That's what we would do. The quantity would go in. Times 2 is 3.73. We typically go with 2 decimals, and this is kind of an interesting point to mention, is that sometimes calculators will run out and have many decimals, so that is going to affect the accuracy and when we compare. So if I do this takeoff and you do this takeoff and you have 4, or some calculators could have 8 decimals, I'll set Excel so that it's only 2, but I'm not going to clear this and get rid of the 5. But just kind of an interesting talking point is we're not, depending on how many decimals each person takes, the numbers are going to be different. Anyway, so that's the square footage of 2. Let's divide that by 27, and now we have the cubic yards. So it is 0.13 cubic yards for the 2 footings. Okay, and in Excel we would be very clear, and I would use the language what they use. I would note that these are the I would call them column footings. Well, then I guess I would So you would have to, typically I would say use the same exact language that they use, but everything is a footing, so you'd have to come up with your own name and call them column footings or pier footings. That's what I would call them, pier footings. Yeah, so use their language as much as possible. So what's on your Excel spreadsheet should match what's on the plans. That's the best way. Yeah, I'll just say that. And then, so we see here, let's just go and talk about the dimensions on the outside then. So this dimension, 28 feet, that is from the outside wall to the outside wall, okay? And here we have 22 feet from the outside to the outside of the foundation walls. Now, if we wanted to estimate this footing, right, below it, we don't have that number. They didn't tell us what that is, but we know. Well, this is where these inconsistencies are going to be bothersome. But let's say here, for instance, yeah, all right, let's do it here, for instance. So here the wall is 12 inches thick. Here the concrete footing is 24 inches thick. The difference between that is 1 foot, right? This is a foot, that's 2 feet. So that tells us that this footing is a foot thicker than the wall. So this is an additional 6 inches, and this side is an additional 6 inches, right? So it's going to be 6 inches of footing, 12 inches of wall, 6 inches of footing. That's how we get that 24. So if we know that this is 6 inches, and then we're going to have to come over here to the 28 feet, and we're going to have to take that dimension and pull it over 6 inches. And this will become 28.6, 28 feet, 6 inches. And then on the same side, I'm not going to pay attention to these exact numbers, but let's say that, let's say it was the same exact situation, which usually it is. This would also come over 6 inches. So while this wall is 28 feet long, this footing is actually 29 feet long. So again, that's what I mean by pulling dimension strings a lot. And then if we were to do the slab, right, the concrete slab inside this space, we would have to take that 28 feet and we would have to get that dimension and pull it in the thickness of the wall, which is a foot. So this 28 would become 27. And then over here, that 27 would be reduced further a foot to 26. Okay, so a lot of maneuvering and acrobatics with the dimensions when it comes to concrete. Okay, this is what a contemporary kind of plan would look like. So it doesn't have all that illustrative kind of information that I was just going through. But anyway, we have our dimension strings. We have, this looks like it's nicely dimensioned, actually. At every jog, we would have a dimension cut. So yes, that all makes sense. And then we have an overall that matches it exactly, and the same here. Jogs, dimensions for every jog. I'm not sure what this is, going here to the center line, and I can't read this, but no matter. We see the concrete walls, the dark walls, and we see the footings below, and there's a lot of interior work going on here as well. Here's the footing schedule. So house and walls, so 20-inch by 10-inch minimum. House walls, decks and porches, bearing wall, garage wall. All right, so we have a couple different things going on. The garage has its own, because it's not supporting as much weight as the house, so it's probably smaller. House walls would be the perimeter, the perimeter of the house. Bearing wall, we would have to figure out either, I don't see anything being called out. I'm not exactly sure where the bearing wall lives. So if we could zoom in and see, we would have a better chance. But somewhere in here, there should be a key and say, like, this is a bearing wall, and those two black walls, perhaps. Wherever they live, they have a different size footing. And then we have decks and porches. So this looks like a porch in the front, and I don't know if there's a deck, or I'm not sure what's going on back here, but suffice to say, schedules have a lot of information too. Okay, estimating concrete. So only include the corner one time. We just talked about that. Footing length and width is greater than wall length. Footing length and width is greater than wall length. Okay, that reads a little strange, but that's just what I was saying, is that the footings are wider. Good practice. Highlight on plans which portions of the footings have been figured or determined, counted for. So if you have hard copies, that's how a lot of contractors will do it. If they have hard copies, they'll have highlighters, or if you have or more often these days, especially for big jobs, you would have a PDF inside of a plant, inside of software that would help with the scaling and everything, and we'll look at that later. But anyway, you want to have some way of tracking which walls have already been accounted for, obviously. No deductions are made for holes smaller than 2 square feet or for the space reinforcing and other accessories take up. So if there's rebar, it's less concrete, obviously, but you don't calculate that, is what that says. And then holes would be if utilities were running through a hole in the foundation or something like that, but or a small window perhaps. 2 square feet is very small, but I would say like utilities entering the basement somewhere, for instance, and that would be you would not bother taking that out. And then here are percentages for wasted concrete, which seem a little high to me. Actually, like 8% is seems like a lot to add. I don't think that much concrete typically gets wasted on jobs. It's not easy to clean up concrete, so who would want to make a mess with it, really? Okay, let's keep moving. Determining the linear feet, and just to follow up on that point, this is a number you would adjust if per your experience. This is not set in stone. Set in concrete, so to speak. No pun intended. It's if your experience shows that you're not wasting all this, then don't add it. Don't buy more concrete. Don't drive up the cost of the bid. So don't just accept these numbers. The best way to come up with this number is by your own historic practice, paying attention, to the amount that is actually your crew is actually wasting. Okay. Determining the linear feet of continuous footing requires some minor calculations because dimensions are typically given on the face of the exterior wall. So that's what I just went through when we were looking at the plans, or center lines, sometimes on structural framing plans, for instance. Overlapping corners you do not want to calculate twice, so we talked about that. Determine the dimensions along the exterior edge and dimension to avoid overlap. Yeah, so adjusting the dimensions, as we said. So linear feet of each piece by its cross section. Yes, we discussed that. And so that's that. Linear feet times width times height, and then we finish by dividing by 27, just as we did. And that is that. Okay. Okay. Thank you. I hope that is helpful to get started. Good luck.